Okay. So today and next class, tomorrow, we will talk about sort of introduction to the measurement. We want to have the big picture. It's very important to understand the big picture and why this course is important to you as a civil engineer. I just uploaded one small video link. As I said, I will do that regularly so that you see the link between what you are studying in this course and in your discipline. So this is a valid question. I am a civil engineer. I want to work on construction, bridges, whatever my discipline will be. Why I need to worry about voltage, current, resistance, circuit, these type of things? What is the relationship between these concepts and my discipline as a civil engineer? So the first thing, which is something very important, yes, civil engineers are concerned about construction, about design of buildings, but part of the design is design of the electrical wiring in the building. So how we connect the wires, the loads, the lamps, the switches, and so on and so forth. Although this course doesn't cover that deeply, but we'll try to cover touch base at the end of the course, and we'll give you a sort of introduction about that. How we design the house, how it receives the power, and how we use it in our house. But we'll try to make it very, very simple. But more important than that, and this is the link between the course and your discipline, is the area of sensors and measurement. As a civil engineer, you use sensors a lot in many, many applications, especially in structure, to monitor the structure. You want to see displacement. You want to see if there is any deformation happen to the building. You want to see sometimes the temperature and monitor the temperature, and so on and so forth. So, in a nutshell, this course, the objective of this course is to provide you with the tools that you will need so that you can build your own measurement system. That is, in one statement, what we are trying to do here. So we will not teach you voltage, current, resistance as an abstract thing, as something that does not relate to you. No. The circuit concept that will be covered in this course, the main objective of it is to prepare you to understand and build your data acquisition system that you will be using in this course, and hopefully after that in different areas. Now, another area which is something very important for civil engineers, maybe more to environmental engineers, is water and pollution sensors. This is something very important, and it's getting more and more of attention. For example, I want to monitor the quality, the water quality in a lake. How I should do that? Again, I have to use sensors. If I want to monitor the quality of air, you know, we live in a very polluted environment, and we want to see how things are progressing. Again, we need to have sensors to be able to measure that. Also, sensors becoming an integral part of the smart home, or in a more bigger perspective, smart cities. What is a smart sensor? Again, we will cover that at the end of the course, specifically in smart home applications. But now you can, through the web app, through your phone, you can switch on and off different things in your house. You can, for example, control your thermostat, your temperature of the house. You can do that remotely. You can make your fire alarm system working on or off. You can monitor your load consumption inside your house. You can switch an appliances remotely through your phone. So all of these things, the main building block of it is the sensor. And we will try during this course to touch base of these applications, and also to give you the needed information so that, or the background, so that you will be able to understand. We don't want you to be like just a user for those sensors. No, You need to understand how the sensor works, how I can select my sensor for my application, how I connect it in a circuit and get some useful information. So that is my quote of the day. I like this quote, that I have a dream that the civil engineers, hopefully by the end of this term, will find electrical engineering something useful and something that they can build on, and something they can use it after this term in their life. So this lecture will be divided into two lectures. Today I will talk about sensors, and tomorrow we'll talk about something else, about how we acquire the data from the sensors. So this is the overall of a measurement system. Start from the sensor, where you measure the physical phenomena. Now, this physical phenomena could be temperature, could be force, humidity, displacement, anything that you are interested to measure. To do that, we use a transducer that will convert this physical phenomena into an electrical phenomena. And eventually, we want to have it as a voltage. Sometimes we do that directly. Sometimes we do that in two stages. So at the end of the day, we will have a voltage signal that we will be measuring. Why we do that? We'll talk about that later on. But sometimes this voltage is very weak, very hard to measure. We need to amplify it. Sometimes, because of the environment, has a lot of noise. We need to filter it. Okay, so we will talk about these concepts, especially the amplifications, later on. Now, I have a clean, nice signal, but this signal is what we call analog signal, continuous signal. Computers doesn't understand that. Remember, at the end of the day, let's say you want to monitor the temperature inside your room, and you want to save the temperature every 30 minutes in the computer. Computer cannot understand this signal. You have to convert it from analog into digital. So we use what we call analog to digital converter. So this data, continuous data, it will be converted to ones and zeros. That's it. Everything will be ones and zeros, and then the computer can be able to deal with this. So this is, in my opinion, one of the most important slides in this course. This is the objective. We want to understand every single building block of those. How we can build them, how we can design them, how we can analyze them, so that we will have, at the end of the day, a measurement system. So we'll start with the sensors. Sometimes they use transducer interchangeably. Sometimes they differentiate between that. We don't want to go too much into philosophy of the names, but what is, at the end of the day, what is the sensor? As I just mentioned, you are interested into a physical phenomenon that you want to monitor. Okay, you want to monitor, for example, the pH in the water. You want to measure the CO2 inside a building. You want to measure a temperature inside an oven. You want to monitor this. So you have a physical phenomena of interest to you. Then this sensor, as I just mentioned, change this physical into something measurable, electrical signal. And here is the link. This is why you need to study an electrical course, because at the end of the day, this measured value will be converted into electrical measurement, voltage, current, resistance, capacitance. As I said, at the end, we'll convert that to voltage. So we need to understand what is the voltage, what is the resistance, what is the current, because these are the things, the quantities that your measurement system will convert them into, starting from the physical phenomena. These are some examples. There are many of more than that of sensors that you will be using in your life. Some of them, maybe all of them, and we will cover some of them in this course. Cover them some in the course material, or in the lab, or in both. So strain gauges and load cells. The word strain gauge, you will hear this term a lot. As a civil engineer who work on structure, you will hear this term a lot, and we'll talk about that in details along with the load cells. thermocouples, or if you make it more general, temperature measurement sensors. Again, as a civil engineer, this is something very important, and we will dedicate some lecture talking about how we measure the temperature. Piezoelectric sensors, this is a category of sensor that will convert vibration into electrical signal. Humidity sensor, you will have in the lab some type of experiments that will deal with humidity. Corrosion sensors, linear variable differential transformer, and this is basically to measure any deformation having in the slabs in a building. Optical fiber sensors, water and air quality measurement sensors, and so on and so forth. Let's talk about these sensors a little bit. So the strain gauge, what is a strain gauge? As I said, we'll talk about these things in details, but this is just an overview of the course. The strain gauge is a small sensor, as you can see here. This sensor, we can put it on beams, on rods, and there are some electrical wire coming out of them, as I mentioned. Okay, I want to measure the deformation in this rod or the deformation in this beam. This deformation is a physical phenomenon, but how to measure it? We need to have an electrical signals coming out of it, and we'll see what is this electrical signal and how it is generated, what is the physics behind that. This is why you see two wires here. These two wires to do the electrical measurement. Now, strain gauges and load cells are somehow connected. So a load cell look like this. And hopefully, if we go back to the lab, you will have some experiments about the load cells. So these load cells are basically, they have the strain gauges in certain arrangement, and they used to measure forces. They are used to measure weights. For example, the weight that you use to weigh yourself or the vegetables in the kitchen, they are using load cells, and we will see that later on. Water level sensor. Sometimes you are interested to see the water level in certain container. There are different ways. There is a capacitive liquid level sensor. There is a photoelectric liquid sensor. Now, when we say photo or capacitive, this is the mechanism of the sensors. We are more interested into electrical sensors, so we will use more of the capacitive sensor more than the photo, but this is just to give you awareness about these sensors. Thermocouples. Thermocouples is a sensor. It's basically two wires connected at one end and loose at the other end. And at one end, you have the source of heat or the source of cold temperature. It can be used to measure both high temperature and low temperature. But at the end of the wire, you will measure voltage directly. And how this is happening, that's what we'll try to understand when we talk about temperature measurement, how we can convert this temperature through a wire into a voltage in something that we can measure. As I said, the LVDT for short, or linear variable differential transformers, are used to measure deflection. So they are connecting, for example, in this beam, and once you apply forces here on this beam, those sensors or those LVDT will start to change their position, and this can be transferred into a change in the inductance. So this is called inductive sensors, which is also another type of the sensors that we will try to cover in this course. Now, I mentioned the following. Now, we are converting a physical phenomena into an electrical phenomena. So, for example, I am measuring voltage. I showed you the thermocouples. There is a temperature, this may be 60, 70 degrees. I am measuring a voltage, let's say 20 millivolt. Okay? I'm not interested in the voltage. I am interested in the temperature. But this voltage is only an intermediate stage. So I need to go back to what I am measuring. So we use calibration curves. Each sensor comes with a calibration curve. For example, this is one of the sensors that we'll study later on. This is a displacement sensor. When you have something is moving, okay, you can do that using this type of sensors, and we'll talk about this circuit in details as we progress in the course. Now, this is the calibration curve, and this is something very important. Why? Because it relates the voltage into displacement. So you will be measuring this, the y-axis, but that's not my interest. My interest is to know this displacement. This could be in millimeter, in centimeter, whatever the unit is. So that's what I want to know. So I have to have the calibration curve. So for example, if I have 3 volt measured, okay, so this means that displacement was 60. Okay, that is of the interest. So I have to have a calibration curve and have to understand. And this comes with the manual of the sensor. It comes always with its calibration curve. So this is something very, very, very important. Now, this relationship, this type of sensors, displacement is a linear sensor, meaning that the relationship between what you are measuring and the voltage is a linear relationship. Or it could be nonlinear. What is this? This is one of the sensors that we'll learn about later on, called the thermistor. The thermistor is basically a non-linear resistance. Now, the change in the temperature is reflected as a change in the resistance. Still, the resistance is an electrical quantity, but we prefer to change this change in the resistance into change into voltage. And we'll talk about that later on. Okay, so for example here, what you measure this, because this is something electrical, I can measure. This is my temperature, so I will find certain resistance, the value of the resistance, okay? And then using this nonlinear curve, I will find what is the corresponding temperature. So this is something very, very important to me, that I need to understand this relationship. And in many cases, it is programmed. This calibration curve, it is programmed when you read the value directly, okay? It is already, this conversion is done through simple programming, and we'll talk about that in the labs and in the course later on. One important issue or aspect of the sensor when you select your sensor is the response time. What do we mean by response time? Any physical phenomena, when it starts to take place, it does not have an effect right away. It will have some time. I will give you an example from our life. Imagine you are inside a room and the temperature was 15 degrees centigrade, and you want to bring a heater to the room so that it heats it up. So you bring a small heater and you turn it on. And you are, let's say, 1 or 2 meters away from the heater. The heating of the room will take some time. There is some response time of the room until it is heated to some comfortable temperature. It doesn't happen right away. Same thing for the sensor. Now, I want to measure the temperature, okay? And the temperature that we want to measure, usually, let's say, a thermocouples, okay? Now, these thermocouples, how fast or how slow they respond to that time, it depends on some design factors of the sensor. So for example, here is 2 different types of sensors, okay? And they have different materials. See this, the sensor in the dark color or the maybe the blue green color is faster. It meaning what? It takes less time to go to the steady state, to reach to the final value. But the red one takes longer time until it reaches to the actual value. Now, which one is good, which is bad? It depends on your application. As a general rule of thumb, faster sensors are usually more expensive. The question is, do you need them? Do you need a sensor to respond to that change in the temperature very, very fast? Does your application require that or not? Let's say, for example, you have a rocket. And this rocket, the temperature change in microseconds. And you need to know what exactly the temperature of the sensor. Then extremely, you need a very extreme fast sensor. But if you are measuring the temperature inside your room, you're using your thermostat. Why you have to respond very fast? You don't have to. It can take its time until it settles down. This is another sensors. It shows also when you have something cyclic, something that change up and down. These are the strains, and this strains is the blue color, so it goes up and down, increase, go up and down, and the red is the sensor which is trying to measure this as a change in the resistance. So this could be like a strain gauge. Okay, so you can see here the sensor is following the change that is happening in the strain. So sensor response time, something very important. And when you do your experiments, there's something very, very important you have to watch. You have to wait to give the sensor some time until its value settles. Let's say that you want to measure, for example, using an ultrasonic sensor, you want to measure the distance. So you bring the sensor, you have your object, you wait a little bit until the values are settled. You reach to the steady state value. You want to measure the temperature, same thing. You will have one of the experiments, you need to measure the temperature. Then you have to give it some time until that you see the temperature are varying, especially if you bring a source of heat to the sensor, you will see that the values are changing, and then it will start to settle down. So understanding this, that the sensor need a response time. You don't just take the value right away. I want to measure temperature. I'm bringing my sensor from an ambient temperature, which is 22, 23 degrees centigrade. And I have a boiling water. And I put the sensor and immediately take a temperature. No, you have to wait until you see that the readings are coming closer, or following this curve until it reaches the steady state and you don't see much variation in the measurement. Then you can take your measurement. Now, as I said, some sensors do that very fast. Some, they take their time to do that. Now, I measured my quantity. I have it as a voltage, and then I need to feed it to the computer. But before feeding it to the computer, I have to condition that signal and make it appropriate. And to condition the circuit, you need to do a couple of things. You need to do amplifications, and you need to do filtering. Okay, so let's have an example here. You have here a weak signal. Let's say the signal is in the millivolt range, very small signal. Now, to measure this, you need a very sensitive equipment, and it could be very, very costly. However, using a simple amplifier circuit, which costs a few dollars, then you can amplify the signal, make it in the volt range, then any ordinary equipment can be used to measure this. So this is something very important. Another issue is that when your voltage is a very low value, the noise around it could be in the same order of magnitude. So you don't know, are we measuring noise or measuring a physical phenomena? This is why we need to amplify the signal to make sure that we are measuring the right thing, which will lead us to filtering. This is an actual signal I measured using an acoustic sensor or ultrasonic sensor. This is basically coming from an electrical discharges. Okay, so this electrical discharge inside a container, and my sensor is at the end of the container, so it's a piezoelectric sensor. So whenever there's an electrical discharge inside, it was oil inside, the medium was oil, then there will be some waves. These waves will hit the structure. When it hit it, it will generate some vibration, a very little vibration in the ultrasonic range. Okay, so we measure that. Now, but when you look to this signal, you don't know actually, are you measuring something here or it is just noise? So we need to filter it out. And when we filter it, see here, now this is way better. Now we can get some information from that signal. For example, the peak value or some other more important information. In this course, we don't teach you much of the filters. If times allow, I might cover it at the end. But because we use certain type of amplifier, we call them differential amplifier and instrumentation amplifier, they can be used to do two things in one thing. They can be used to amplify and filter the signal. So that will be most likely we'll be teaching, and we will not cover much of the filters. I will stop here. Next class, we will be working on data acquisition system.